For generations, humanity has searched the heavens for answers, believing we were slowly uncovering the secrets of the universe. But today, everything may have changed. The James Webb Space Telescope has captured observations so extraordinary that they are forcing scientists to question decades of accepted theories. Ancient galaxies appearing far too early, colossal planets that shouldn't exist, perfectly organized cosmic structures, and a mysterious rhythmic signal unlike anything ever recorded. These aren't just surprising discoveries, they're clues pointing toward something far bigger than anyone expected. Before we go any further, please subscribe to our channel and help us reach our goal of 1,000 subscribers. Your support helps us bring you the latest mysteries and groundbreaking discoveries from across the universe. Because what James Webb has revealed isn't just another scientific breakthrough. It's a direct challenge to everything we thought we knew about the cosmos. If these observations are confirmed, they could rewrite the story of our universe forever. The question is no longer what we're looking at, but whether we're finally seeing reality as it truly is. And if that's true, it would mean our entire understanding of the cosmos needs to be rewritten. During a series of groundbreaking deep-field observations, the James Webb Space Telescope captured some of the clearest and most detailed views of the distant universe ever recorded. But those breathtaking images contained far more than stunning beauty. Hidden within them were discoveries that challenged some of astronomy's most fundamental assumptions. One of the most intriguing findings came from the galaxy cluster Abell 2744. Researchers identified remarkably precise points of light and highly symmetrical arrangements that seemed completely out of place in a universe believed to evolve through chaotic processes. Another surprise emerged from the spiral galaxy NGC 1365, where astronomers detected unusual gravitational motions that didn't match the predictions of current models. And these weren't isolated cases. As Webb continued looking deeper into space, similar anomalies kept appearing. Across billions of light-years, scientists found repeating patterns and astonishing geometric precision where randomness was expected. At first, many dismissed the observations as statistical coincidences, but as more evidence accumulated, that explanation became increasingly difficult to defend. The similarities were simply too consistent, too widespread, and too exact. A bold possibility slowly entered the discussion. Perhaps the universe isn't governed by randomness alone. Perhaps beneath the apparent chaos lies a hidden order that humanity has yet to understand. Among Webb's many observation targets was the distant exoplanet HIP 65426b, located hundreds of light-years from Earth. What astronomers found there was equally astonishing. The planet is roughly 7 times the mass of Jupiter and orbits its parent star at nearly 3 times Neptune's distance from the Sun. Even more surprising, its host star is only about 15 million years old. According to today's leading theories of planetary formation, a world like this shouldn't exist. There is no obvious protoplanetary disk surrounding the star, no remaining material capable of building such a massive planet, and no widely accepted mechanism explaining how it could have formed so quickly, so far from its star, while remaining in a stable orbit. These unexplained details have sparked speculation among some researchers. Could HIP 65426e have originated somewhere else entirely? Might it be the surviving remnant of an earlier planetary system, a world that somehow endured the destruction of its original star before becoming part of a new one? At this stage, no one knows. All we have is a giant planet glowing at temperatures above 1,000 degrees, orbiting within a system that, according to current science, should never have been able to create it. Another extraordinary observation came in the form of an Einstein ring, a spectacular effect produced when the gravity of a foreground galaxy bends and magnifies the light from another galaxy directly behind it. The example Webb captured around galaxy J418, however, was unlike almost anything seen before. Instead of an incomplete arc, it formed an almost flawless circle of light with extraordinary mathematical symmetry. Even veteran astrophysicists were amazed by its precision. For an Einstein ring this perfect to appear, the alignment between the two galaxies must be almost exact, differing by only tiny fractions of a degree, despite being separated by billions of light-years. While gravitational lensing itself is a well-understood phenomenon, achieving this level of perfection is exceptionally uncommon. The observation has prompted scientists to ask whether something deeper may be influencing the structure of the universe. Could space-time itself possess an underlying symmetry we have only begun to recognize? Could the cosmos be shaped by elegant geometric principles rather than pure cosmic randomness? Yet, perhaps Webb's most astonishing discovery involves the earliest galaxies ever observed. The telescope has identified enormous, well-developed galaxies that already existed only about 180 million years after the event we call the Big Bang. In astronomical terms, that is incredibly early. Current cosmological models predict that galaxies should still have been small, irregular collections of gas and newly forming stars. They simply shouldn't have had enough time to grow into massive organized systems or shine with the brightness Webb has measured. Yet many of these newly discovered galaxies appear comparable in size to the Milky Way, already mature, stable, and highly structured during an era when the young universe was expected to be turbulent and disorganized. These observations have forced cosmologists to confront one of the biggest challenges in modern astronomy. If the measurements are accurate and repeated observations continue to support them, then key parts of our understanding of cosmic evolution may require major revision. For decades, the Big Bang has served as the cornerstone of modern cosmology. But discoveries like these are leading some scientists to ask whether the story is more complex than we ever imagined. Perhaps the universe's history stretches back further than our current models allow. And if that's the case, humanity may only be beginning to uncover the true origin of the cosmos. In one of the most puzzling regions ever examined, far from any large galaxy, the James Webb Space Telescope detected a gravitational effect that shouldn't have been there. The surrounding space appeared almost empty. No visible stars, no galaxies, no black holes. And yet, the light from far more distant galaxies was bending and warping as though an enormous source of gravity were hidden in plain sight. The most widely accepted explanation points to dark matter, the invisible substance believed to make up much of the universe's mass, while remaining impossible to observe directly. But this particular phenomenon doesn't fit comfortably within that idea. The lensing effect is unusually concentrated and remarkably powerful. Instead of behaving like a broad, scattered cloud of dark matter, it resembles something with a clear shape, defined boundaries, and a measurable gravitational center. Could dark matter somehow be gathering into organized structures that current physics has yet to explain? Or is this strange distortion the lingering imprint of something that existed long before the galaxies we see today? A handful of physicists have even begun exploring more unconventional possibilities. Rather than an invisible cloud of matter, could this be the gravitational signature of an ancient structure? Something no longer visible, yet still capable of bending space itself? Another Webb observation has generated equally intense debate. The telescope revealed an enormous intergalactic filament stretching for more than 1 billion light-years, linking galaxies and matter in an astonishingly precise arrangement. Filaments are not new. They are considered part of the vast cosmic web that connects galaxies across the observable universe. But this particular structure stands apart from the rest. Its near-perfect alignment, unusually dense regions, and repeating gaps give it an appearance that resembles an immense cosmic framework rather than a naturally formed filament. Conventional cosmology explains these structures as the result of gravity slowly shaping matter over billions of years. Yet the extraordinary symmetry seen here has become difficult to ignore. Galaxies appear to follow nearly parallel paths. Dark matter concentrations occur at remarkably regular intervals. Even the redshift measurements display a repeating wave-like pattern, suggesting an unexpected level of order within this region of space. Many researchers urge caution, reminding us that the human mind naturally searches for patterns, even where none actually exist. Others, however, have raised a more provocative question. If intelligence ever played a role in shaping the universe, could structures like this represent its earliest and most subtle traces? As scientists continue investigating these gravitational mysteries, another once-fringe hypothesis has started receiving renewed attention. What if dark matter is more than invisible mass? What if it somehow preserves information? Not information in the conventional sense, but a kind of cosmic memory encoded into the structure of space itself. Several Webb observations have revealed galaxy clusters arranged in ways that appear strikingly similar to formations found elsewhere across the universe, almost as though ancient patterns are repeating themselves over unimaginable spans of time. This has inspired an intriguing possibility. Perhaps dark matter retains gravitational imprints from earlier cosmic eras, quietly influencing where future galaxies take shape as the universe continues to evolve. It is an idea that sits somewhere between theoretical physics and philosophical speculation, suggesting that the universe may possess not only an origin, but also a memory of everything that came before. If such a concept were ever proven, every spiral galaxy, every immense cluster, and every seemingly empty void could represent chapters in a design far older than humanity has ever imagined. Yet the most unsettling observation associated with Webb may be the one discussed least openly. During a deep-field survey focused on an enormous cosmic void, the telescope recorded a sequence of faint light pulses unlike any previously identified. The signals were far too regular to resemble random fluctuations, yet too weak to match the behavior of known stars. They did not resemble pulsars. They did not match quasars. They appeared at perfectly consistent intervals before disappearing entirely. The first assumption was that the data contained an error, perhaps an internal reflection, electronic interference, or a processing artifact. But after repeated analysis using independent verification methods, the same pattern continued to appear. Even more puzzling, the apparent source contained no detectable star, no nebula, no measurable heat signature, and no obvious object capable of producing the flashes. Only a faint, precisely timed pulse emerging from what seemed to be empty space. For now, no definitive explanation has been confirmed. Yet, behind the scenes, one unsettling question continues to surface. What if the signal was never intended to communicate with us, but simply to announce its presence? And if that's the case, who or what was it actually meant for? The James Webb Space Telescope was designed to look backward through time, allowing humanity to witness the earliest chapters of cosmic history and revealing what the universe looked like billions of years before our own existence. Yet the deeper James Webb peers into the universe, the more it challenges not only our scientific theories, but our place within the cosmos itself. Every new observation seems to raise a question that is even more profound than the one before it. Instead of delivering simple answers, the telescope continues to reveal mysteries that push the limits of human understanding. For generations, we believed we were simply spectators, tiny observers watching an unimaginably vast universe unfold before us. But what if that assumption has always been incomplete? What if humanity is not standing outside the cosmic story, but has always been part of it? Across billions of light years, Webb has uncovered mature galaxies that appear far too early in cosmic history. Enormous planets that seem impossible according to current formation models, gravitational effects with no visible source, and structures whose remarkable precision appears almost intentional. Each discovery, viewed on its own, is fascinating. Together, they form a collection of mysteries that continue to challenge some of the most established ideas in modern astronomy. These are not scenes from a science fiction movie or imaginative speculation without evidence. They are genuine observations collected by one of the most advanced scientific instruments ever built. The images, measurements, and data are real. The debate surrounding their meaning is real. And with every new observation, scientists are forced to ask questions they never expected to confront. Could these patterns simply reflect natural processes we have not yet learned to recognize? Or are they pointing toward principles of the universe that remain completely hidden from today's understanding of physics? If the repeating structures truly carry deeper significance, if the unexplained signals eventually reveal an identifiable source, if the strange gravitational distortions are evidence of something beyond our current models, then humanity may be standing at the edge of one of the greatest scientific revolutions in history. Perhaps the universe is far more interconnected than we have ever imagined. Perhaps every galaxy, every filament, every mysterious void, and every invisible force is part of a much larger design whose purpose remains beyond our present understanding. And perhaps the most unsettling thought is not that intelligent life may exist somewhere among the stars. It is the possibility that the universe itself may operate according to rules we have only begun to glimpse. For centuries we've searched the heavens hoping to discover whether we are alone. But the next great question may be even more profound. What if we have never truly been separate from the universe at all? What if every discovery James Webb makes is revealing not only the history of distant galaxies, but pieces of a much larger story, one in which humanity also has a role to play? Maybe these extraordinary observations are simply natural phenomena awaiting better explanations. Or maybe they are the first hints of something that has remained hidden for billions of years, patiently waiting until civilization possessed the technology to finally notice. Whatever the truth may be, one thing is becoming increasingly clear. The James Webb Space Telescope is doing far more than photographing distant stars. It is challenging humanity to rethink its understanding of reality itself. So now we'd like to hear from you. Do you believe these remarkable discoveries are simply expanding the boundaries of science? Or do you think they hint at something far more mysterious, something we have yet to fully comprehend? Share your thoughts in the comments below. We'd love to know where you stand. And if you're fascinated by the greatest mysteries of the universe, don't forget to subscribe and turn on the notification bell. Every new image captured by James Webb has the potential to reshape everything we think we know about space, time, and our place within the cosmos. Because the next discovery may not only reveal where the universe began, it may reveal where humanity's greatest journey is only just beginning. Until next time, keep looking up, keep asking questions, and we'll meet you again beyond the veil.